AI applications such as large language model, generative AI, and semantic search require large amount of data to train and operate. Efficient data processing is essential for making AI applications successful. Many of the latest AI applications relies on vector embedding, such as Chatbot, question answering system, and machine translation, which means converting text into numbers that contain within themselves semantic information. Vector embedding converted text into a set of numbers in a high-dimensional space, and the numbers themselves contains the meaning of the word. This is critical for AI application to gain understanding and maintain long-term memory. There are many vector databases, both free and commercial. Some of the most popular ones are Pinecone, ChromaDB, and Malvis. In today's video, we are going to dive into ChromaDB and explore how to use it in your project. So without any further delay, let us get started. Hello everyone and welcome back to my channel. ChromaDB is an open source in-memory vector store, which makes it better fit for small to medium-sized projects. You don't need a separate server or hosting for it. Plus, you don't have to mess around with indexes and namespaces. Before we start our hands-on tutorial today, there are some important definitions that we need to address, such as what is text embedding, Cosine Similarity, Euclidean Distance, RAG, and vector database pipeline. We will start with text embedding definition. Text embedding are numeric representation of text that lets computer compare words and phrases based on their meaning. We can compare how similar different pieces of text are using techniques such as Cosine Similarity and Euclidean Distance. This is the basic foundation for building an amazing AI application, from organizing your document to a chatbot that truly understands what you're asking for. But why do we need text embedding? As you know, when working with natural language processing models, we are working with text. Machine and algorithm doesn't deal with text easily. Words and phrases are good for a human, but not for machine. That's why for many different applications, we need to represent our text in a numerical format. Cosine similarity technique measures the angle between two vectors. It focuses on the direction on which the vector points, not their size or magnitude. The value ranges from -1, which means opposite direction, to a value of 1, which means same direction. A value of 0 means that the two vectors are unrelated. This technique is great for comparing text or data in which the relative sizes of vectors reveal similarity. For example, comparing a document of different lengths. Euclidean distance is a straight line distance between 2 points in the space. The value of it is always a positive number. The larger the distance, the less similar the vectors are. It is useful to use when the magnitude of the vector is important. For example, comparing images based on their pixel intensity differences. RAG stands for Retrieval-Augmented Generation, a technique that combines the large language model with a way to search for information. This lets the model to look at stuff like private documents and databases while generating text. RAGs overcome a knowledge limit and makes its answer more factual while lets the model handle complex questions. Let's break down the image into 3 steps to understand how vector database work: embedding, indexing, and querying. The first step, embedding, is to create a vector embedding model such as OpenAI text embedding. The second step, indexing, is to insert the vector embedding into the vector database. This is done by associating each vector embedding with a reference to the original content used to create it. And the third step, query, is to query the vector database for similar content. This is done using some embedding model to create the vector embedding. The embedding model is used to create a vector embedding for the query. And this sector embedding is then used to query the database for similar vector embedding. The similar vector embedding are then associated with the original content used to create them. To illustrate, let's imagine a company that wants to store and query its private documents. The company would first use an embedding model to create vector embedding for each document. Then these vector embedding would be inserted into a vector database such as Pinecone or ChromaDB. Then each vector embedding would be associated with a reference to the original content. Finally, the company can use the vector database to query for information similar to a given query or question. For instance, the company could query the document or a product description. Vector databases are much more efficient for storing and querying unstructured data and are heavily used in large language model applications. Alright guys, for today's tutorial we are going to develop a question-answer application using our own private document, and we are going to use LangChain and ChromaDB. The requirement for this application is to have an OpenAI API key. So if you don't have one, please go to OpenAI website and generate your own API key. I have already generated my own API key and stored it in a .env file in the same location as the Jupyter notebook we are going to work on. The first step is to install the required libraries. We are going to use OpenAI, LangChain, ChromaDB, .env, TickToken, PyDF, and document to text. Alright, so we need the following libraries. So we'll run the code and it's completed. The next step is to load the environment variable. So we'll have here load environment variable. First we are going to import OS, then from .env we are going to import load underscore .env and find underscore .env as well. Then we'll say load underscore .env find, and then we'll set override to true. After that we'll say os.environ.get. We are going to get our open AI underscore API underscore key. And finally we are going to print a true message if the API key loaded successfully. So we'll say API key loaded, and then we'll say os.environ.get open AI underscore API underscore key. The condition is not none. Let's run the code. I get an error here. This is load underscore .env, and the API key loaded successfully. Now before we start implementing ChromaDB, we have to define three functions. The first one is to load document with different format. Load documents with different formats. And the second one is to create our chunk strategy. So here we'll have another function for chunking strategies and splitting the documents. And the third function is to generate answers from vector store. So here we will have create the function for generating questions and answers. Okay, we'll start first with the load document with different format. So we'll say here define extract underscore text underscore from underscore document, and the only argument that it will have is the file. We are going to import OS Then we are going to say here name and extension is equal to os.pass.split text file. We are going to split the file into a name and extension. And then we are going to check if the extension of the file is equal to .pdf. Then we are going to say from LangChain .document loader import by PDF loader. Print. We are going to say loading the file. And then we are going to say loader is equal to by PDF loader file. Else, if extension is equal to, we are checking here if the file is a Word document. Then we'll say from LangChain document loader import docx to text loader. Again, we are going to print a message to the user, loading file, and then we'll say here loader is equal to doc, and we are loading the file. And finally, else print document format is not supported by our application, since we are going to use here only either PDF or Word file. And then we are saying return none. Now, since we load the document, we are going to define here a variable data which is equal to loader.load, and we are going to return the data. Let's run the code. Now we will create the second function, which is called split text into chunks. So we'll say here define split underscore text underscore into underscore chunks data that we are going to pass, and the chunk underscore size is equal to 256. The primary purpose of this function is to take a piece of text and break it down into smaller, more manageable segments. By this we mean chunks. This is crucial when working with language models that often have input size limitation. Now, from LangChain, we are going to say text splitter dot import recursive character text splitter. Recursive character text splitter tool is designed to intelligently split text segment. Its recursive nature means it repeatedly evaluates the text to find the ideal breakpoints for creating balanced chunks. This chunk size parameter determines the desired approximate size in character of each chunks, and here we use the value to 256 character. Next we'll say text underscore splitter is equal to recursive character text splitter, and we'll use chunk underscore size is equal to chunk underscore size, and chunk overlap we are setting it to 0. This chunks overlap parameter control how much text should overlap between consecutive chunks. In this example, we set it to 0, meaning there won't be any overlap text between the chunks. After that, we'll say chunks is equal to text splitter dot split documents, and we are going to pass our text here. And finally, we are going to return chunks. Let's run the code. So this function will return the list called chunks. This list will contain the individual text segments that have been created from the original input data. Now we will create a function called generate answer from vector store. The goal of this function is to take a question and provide an answer by utilizing a vector database, which in our case we are going to use ChromaDB, and a language model, which we are going to use the OpenAI. So we'll say here define generate underscore answer underscore from underscore vector underscore store. So we are going to say here vector underscore store, which is going to be the first argument, and the second argument is the question from the user. Next, we are going to say from LangChain dot chains import retrieval QA, and then from LangChain underscore OpenAI import chat OpenAI class. This chain retrieval QA is designed to combine information retrieval, finding relative data, with a language model ability to generate text-based answer. Chat OpenAI acts as a large language model component, which we are going to specify to use GPT-4 with a temperature of 1. So here we'll say LLM is equal to chat OpenAI model is equal to GPT-4 and temperature is equal to 1. Now we will work on the vector database integration. So we'll say retriever is equal to vector store dot as underscore retriever. This will convert our ChromaDB vector store into a retriever, which means the code will search our vector store to find pieces of text relative to the question, and we are going to use here similarity search. So we'll say here search underscore type is equal to similarity and search underscore quarks equal K3. This means that it will retrieve the top 3 most relevant pieces. Now we will create our chain. So we'll say chain is equal to retriever QA dot from underscore chain underscore type. Our LLM object is equal to LLM chain underscore type. We are going to use the stuff chain, and retriever is equal to retriever. This chain combines our question answer language model LLM, the information retrieval power of our vector database retriever, and specifies the type of chains as stuff. Chains of type stuff retrieve relevant information and then use the large language model to process that retrieved information to generate an answer. After that, we'll say here answer is equal to chain.invoke, and we are going to pass our question and return the answer. A chain.invoke run our question through this combined system. Then the relative information is retrieved and the large language model process it to generate an answer. Let's run the code. Now we will start working on implementing a ChromaDB vector store. We have to create 2 functions. The first function is to create embedding. So here we'll say define create function or function for embedding. We'll say here define create underscore embeddings underscore Chroma. The primary goals of this function is to generate text embedding vector, which is vector representation of our text, and then to store this embedding in a ChromaDB vector database for later use. So this function will receive 2 arguments. The first one is the chunks that we created in the previous step, and then the persist underscore directory where we are going to store it, which is going to be equal ./chroma underscore db. Then we are going to say from LangChain dot vector store import Chroma, and from LangChain underscore OpenAI import OpenAI embedding. It's not there, so let me type it, OpenAI embeddings. Chroma here is a vector database provided by LangChain. It's optimized for storing and searching through text embedding. And OpenAI embedding here provides an easy way to interface with OpenAI embedding model. Next, we'll say embeddings is equal to OpenAI embeddings. And for model, we are going to use text-embedding-3-small. And dimension is equal to 1536. Here we are using the text-embedding-3-small model with an output of 1536 dimensional vector. Then we are going to say vector underscore store is equal to Chroma dot from underscore documents. We are going to use the chunks, embeddings, and persist underscore directory is equal to persist underscore directory. And finally, we are going to return the vector store. The Chroma here takes the chunks that we produced before and passes them through the OpenAI embedding model, which is called embedding, to generate vector representation. So here Chroma.from document create a new ChromaDB database. And here's what's happening exactly. It takes our chunks and their corresponding embedding. It stores them in a directly specified as persist underscore directory, which we set the default value of it here to .chroma underscore db. And finally here we are returning the created vector store object, which is our ChromaDB database now containing the text embedding. Let's run the code. And now for the final function, we are going to create a load embedding function. So we'll say here, define load embedding function. All right. The main purpose of this function is to load a pre-existing ChromaDB vector database containing the text embedding, which we created in the previous function. So we'll say define load underscore embeddings underscore Chroma persist underscore directory, which is equal to the same directory we specified before, Chroma underscore db. Then we're going to say from LangChain dot vector store import Chroma, and then from LangChain underscore OpenAI import OpenAI embeddings. Then we are going to say embeddings is equal to OpenAI embeddings model is equal to text dash embedding dash 3 dash small, and the dimension same as we said before is equal to 1536. Then we'll say vector underscore store is equal to Chroma persist underscore directory is equal to persist. Yeah, here I have a spelling mistake. This should be directory. And then let me copy paste it. Okay. And then embedding underscore function is equal to embedding. And then we are going to return vector underscore store. Let's run the code. So this function returns the loaded vector store object, which is the ChromaDB vector store that we created here. Alright, now let's start testing our code. So let's say here, testing. So we'll say here data is equal to extract. We are going to use extract text from document functions that we created before. I have here a file in a directory called files about Google Gemini family. It's in PDF format. I have this file that I'm going to load the text from it. After loading the text, we are going to say chunks. We are going to divide the text into chunks. We'll say here chunks equal to split underscore text into chunks. We are going to pass data, and we are going to specify the chunk underscore size to equal to 256 character. Then we are going to call the vector underscore store is equal to create underscore embedding Chroma, and we are going to pass our chunks. Let's run our code. It's loading now the text from this PDF document, and it's completed. So we have created here our vector database using ChromaDB, and we can now start sending questions. So we can say, for example, question, what is Google Gemini family? Okay, and then answer is equal to generate answer from vector store, the functions that we created before. We are going to pass our vector store here, and we are going to pass the question as well. Okay, and then finally we are going to print the answer result. Okay, so this generate the answer from vector store is this function that we created here. It could be any type of vector store, could be Pinecone or Malvis, but for this example we use the ChromaDB vector database. So let's run the code and check, and we get the result here, which is the answer to our question. Of course, we can send multiple questions as well, and we can add even memory to the chat so that we can create it as a chatbot. Alright guys, this is just a simple implementation of ChromaDB. If you want to see an advanced example about how to use ChromaDB by adding memory to the chat or by creating your own custom prompt and use different chain type, please let me know in the comment below this video, and I will create a video for you. Okay? Alright guys, that's it for today's tutorial. I hope you learned something new and enjoy this tutorial. If you like this video, don't forget to share, like, and subscribe. And if you have any question or comment, please leave it down below this video in the comment section, and I will get back to you. Stay tuned for future tutorial, and happy coding.